Okay, here, lesson 5.4, we're going to move forward with Euler paths and circuits. In your reading, you should have come across Fleury's algorithm for finding an Euler circuit or a path. And here it is. I copy and pasted it out of the book. It is on page 182 of your textbook. So this is coming directly from page 182. So you should reference this when you're starting out trying to do these things. First thing, we have some preliminaries. Make sure the graph is connected and either has no odd vertices, that would make it a circuit if they're all even, or has just two odd vertices. Remember, if it has more than two odd vertices, we cannot have an Euler path. So we start by choosing a vertex. If you have an Euler circuit, it can be any vertex in the graph. But if you have just two odd vertices, you have to start at one of the odd vertices. Okay, and then at each step, if you have a choice, when you get to a vertex, if you have a choice for leaving, this is the important part. Do not choose a bridge of the yet to be traveled part of the graph. Okay, so we don't want to cross a bridge unless we have to. And then in the end, if you have a circuit, it's complete. And you'll be back at the starting vertex if you have a circuit. If you have a path, you should be ending at the other odd vertex. So here we go. We will start with number 29 on page 195. So we'll scroll over here. I've copy and pasted these. And remember, this is number 29 here is on page 195. Okay, so the first thing I'm going to do is, and you shouldn't really have to do this every single time, but if you're having trouble deciding where to start, the first thing you should do is label the vertices with their degree. So here we have a degree 2, degree 2, degree 4, degree 6, degree 6, degree 4. Down here on the bottom, we have 1, 2, 3, degree 4, degree 6, degree 6, degree 4, degree 2, and degree 2. So notice we have all even vertices here. Since these are all even, it doesn't really matter where we start. And what you're going to do is you're just going to trace a path through here by numbering where you start. Tell us where you started, and then just number the edges as you go through. I'm going to start over here on the left-hand side. I'm going to get rid of these degrees so that they're not confusing. And I'm going to start here. There's my start. Okay, and since this will be an Euler circuit, remember, I'm also going to end there. So all we're going to do is we're just going to trace a path through here like this. So we'll start here, and we will go here for 1, down for 2. I will go across for 3. Notice this is not a bridge because this is not the only edge that keeps this connected. So that's 3. I'm going to go up here for 4. I'm going to go down here for 5. I'll go down this way for 6, 7, 8. Then I'm going to go inside here. I'll go this way for 9. That takes me back up to this vertex. Okay, I will go across here for 10. I will go diagonal this way for 11. I will go across the bottom for 12. That leaves me at this vertex. I'm going to go across here for 13. Then I'm going to go diagonal up for 14. Then I'm going to go back down for 15. Then I will go diagonal this way for 16. Then I will go down for 17. Then I will go this way for 18, 19. I will go diagonal up for 20. I will go across for 21. I will go down for 22. That leaves me back here. I'll go across for 23 and then back up for 24. Notice I started and stopped at the same spot, making this my Euler circuit. So really, that's all we're really doing is trying to find a way through this graph, hitting every edge exactly once. And it's an Euler circuit again because we start, and ended at the same spot.